Well, good evening. And tonight we're going to look at an important acoustical relationship on a violin that really makes a difference in the way the violin plays, play up to capacity or not. And that's the side tap of the neck. And where we're going to measure that is at the junction where the nut, which is the ebony block of wood here, the fingerboard, and then the neck wood meet. So just at this junction. And you can just stop the strings with your fingers. And we want that to match the back, which would be G, the note below middle C, G, and it should be 198. And if those match, you got to match them on both sides. And this violin, the side's a little bit lower. We're going to try to correct that. And it makes a big difference in the way the violin plays and the tone and the power. So if you think about the vibrating string, as the string vibrates, half of the vibration goes up this way and half the vibration goes down toward the tailpiece. And when it gets over the bridge changes the motion from sideways to vertical, and it makes the top plate go up and down. And because it's connected to the back with a sound post in here, it also makes the back vibrate in that direction. And of course, this is quarter sawn wood, so the grain is going this way. And so it's important for the neck wood to have the grain, the growth rings going this way, because it transmits sound better. And because this vibration is sideways, we want the wood grain of the fingerboard and of the neck to be horizontal. That's also the way the bridge is. If you look, the grain goes across like this. It's the growth rings you can see on the outside edge. Alright, so we want to make this same as the back, center of the back. You can just use your nickel if you want. And so 198, that's real important. So another way we can do this, if you have a wood tone reference tool, these are 22.4% of the overall length in, this little strip of felt here, so it pivots on those points. And you'll see the instructions for a wood tone reference tool under Tools, Useful Tools on the website. And there's also a calibration file so you can put these different frequencies on here. Just match them up, and then you'll have an accurate tool for measuring the adjustments on your violin. 176 is going to be top plate, fingerboard, nut, string bar on the tailpiece, saddle, and end pin, tap down. Those are all matched to the top, and pretty much everything else will be 198, which is the G below middle C. Okay, so let's go ahead and get started. Now, just to show you how we use the wood reference tap tone tool, the idea is you have some sound post material. This is spruce, of course, and this would be like a viola sound post, about 6 inches long, and you just stop your strings, you drop it and catch it. Don't do this, but you drop, you let it go, and as it bounces up, you catch it. You want to go about 5 times, and you just listen. You don't try to think about it or talk about it, just listen to it. And you come over and you start at a point that's too low, and just go up and listen to the tone that's being produced. So. So there's a point here where you hear the tone going up, and then you come below that point, it goes down. Check it. And you find it's right here at 198, which is the ideal frequency for the back. So that's how you use the try it one more time. This would be for the top plate. And that's how you know you can bracket it, and sure enough it's 176, which is the top plate ideal frequency. So let's go ahead, and since these don't match, and this is the right one, and this is the low one, and I'll show you the easy way to do it. We're going to make this adjustment by moving, either adding material to or removing wood from this block of wood in the back of the peg box. And you don't have to take the strings off, and really you should do this adjustment with the pegs and the strings on. So we'll just loosen the G string, pull it to the side, you can get a little more some tension, then loosen the D string and pull it over the G. E string, drop it down to the side, a little tension, that'll keep the bridge and the sound post in position. Loosen the A, put it down. Alright, now, as you can probably see here, we have complete access to this back surface. So if this side tap here is too low, all we're going to do is remove some of the wood from this back surface. And if one side's lower than the other, remove more wood from this side. If this is low, and if that side's low, you remove more wood from this side. Now if these are too high, you have to add some maple wood and glue it on this back surface, kind of match the shape, and like wood that would be like the maple that you use for making ribs, and just glue a sheet on at a time, and then wait a day after it dries, and then adjust it. If it gets so it's lower than the back, lower than 198, and as you carve it away, you want to bring it back up. So in this case, the side's a little low, so I'm just going to carve. Usually use a file or a chisel, gouge, something like that. And I've just got a sharp pocket knife here. I'm just going to see if I can't whittle this down just a little bit. Won't take too much. Okay, let's listen. Let me try it this way. Still slightly low. Alright. .198, a little below, sounds down, above, sounds, okay, so real close. Alright, so that's all there is to it. And then to put the strings back, start on either side, and this would be the D string back, and the G string, and the E string, and the E string. Okay, and then you have to retune it, of course. And I think you'll find that that plays a lot, plays at its optimum. And so that's just the fingerboard side frequency tap tone adjustment. So this is too low, take some wood away and take the more wood away from the side that is lowest on, bring them together and bring them up until it matches the back, which should be 198. Okay, that's all there is to it. You'll find that this is very useful and very helpful, and if you have a wonderfully performing violin, I think if you just tap like that, you'll see that they match. Okay? Thank you.